Okay, we're going to be working on the sum of the interior angles of a polygon. And basically what that means is if I add all the angles up of the polygon, that would be the sum of the interior angles. So most of you already know that the sum of the interior angles of a triangle are 180, but you don't really know the sum of the angles of any polygon. And really, that's what we're going to be taking a look at, any polygon. Okay, so let's just go over the table we have here. In the first column, we have a shape. And in the second column, we have the number of sides of the shape. Now, notice I'm going up by one, and I start with three, because there is no such thing as a two-sided or a one-sided shape. So the smallest amount of sides possible is three. And from there, we go in order, consecutive order. And here I'm going to go all the way to 12, but I mean, if you have time on your hands, you can go to as many as you want. But I'm going to teach you how to find the some of the interior angles of any kind of polygon. So if I said to you, for example, what is the some of the interior angles of a 723 sided polygon, you would be able to know. Now, I don't know why you would want to know, but you will be able to know really quickly in seconds. Okay, so let's look at the first row. We have a triangle, number of sides is 3. Now over here we have number of triangles. Now what that means is the number of triangles inside that shape. Well, the number of triangles inside a triangle is 1. There's just one triangle here. Okay, the sum of the interior angles we already know is 180. So I'm just going to put that there. Okay, now let's take a look at a quadrilateral. Now, a quadrilateral is a four-sided shape. 1, 2, 3, 4. That's why I have a 4 here. Now, the number of triangles, this is how you find it out. You pick any vertex, and then from there, you draw triangles without overlapping your lines. So from here, like going this way wouldn't do me any good, so I'm not going to go that way. Okay, I'm going to go from here to here, and notice that I have created a triangle right there. And also notice that I have created another triangle right here. And you can't make any more lines than that. So notice that I have 2 triangles. And since I have 2 triangles, each one of them has a sum of 180. So I have 2 times 180 here. And that would give me 360. Now let's take a look at the next one. Okay, so here I have a pentagon, and a pentagon has 5 sides. And I'm just going to pick any vertex, and I'm going to create triangles from that vertex. Okay, that's all I can do right there. So notice that I have 1, 2, 3 triangles. So I'm going to put a 3 here. And because there's 3 triangles, that's 3 180s. And that gives me 540. Okay, let's move on to the next one. All right, here I have a hexagon. A hexagon has 6 sides. And let's see how many triangles I can draw. So I'm just going to randomly choose a spot. That's my vertex. And I'm going to draw a triangle. 1, 2, 3. That's all you can do. And notice that that gives me 1, 2, 3, 4 triangles. And therefore that's 4 times 180, which gives me 720 degrees. And for the next one, this is a heptagon. A heptagon has 7 sides. Okay, I'll just show you where they are because this doesn't look like a normal heptagon, but it is. 1, 2, 3, 4, 5, 6, and this really long side is 7. Okay, so this is a 7-sided figure. All right, now let's take a look at how many triangles we can draw. And I'm going to pick any vertex, and I'm going to go to another vertex. 1, 2, 3, 4. That's it. I can't do any more. Now let's count how many triangles. 1, 2, 3, 4, 5. So that's 5 triangles, which means that's 5 times 180. And 5 times 180 is 900. Okay. Now, hopefully you're able to pick up on some kind of pattern at this point. If not, that's okay. I'm just going to keep going for a couple more. Okay, so here I have an octagon. This is not the way I'm sure you're used to seeing an octagon. This is an irregular octagon. These are actually all irregular shapes. Irregular. Irregular means that the sides are not all the same. Okay, so all of these are, I specifically chose polygons where the sides were not the same. And that's because I wanted to show you that this works for all polygons. Okay, so I'm going to choose any spot, any vertex, and I'm going to start making triangles. 1, 2, 3, 4. Don't forget this one right here. 5. Okay, and let's count the number of triangles that is. 1, 2, 3, 4, 5, 6. So that's 6 triangles, which means we're going to do 6 times 180, and that gives us 1080 degrees. Okay, so I have a whole bunch of others here, but before we move on, I want to see if we can come up with some kind of pattern. So let's take a look at a triangle. Now I want to actually fill in the number here. So notice how here we have 4, then 3, then 2. So if I'm to follow that pattern, I'm just going to put a 1 times 180 there. Okay, just so we can have a pattern. So notice that the number of sides here is 3, but the number we multiply 180 by is 1. And the number of sides here is 4, but we multiply by 2. The number of sides is 5, but we multiply by 3. Okay, in other words, if we have 3 sides, the number of triangles is 1. If we have 4 sides, the number of triangles is 2. If we have 5 sides, the number of triangles is 3. If we have 6, then we have 4. 7, then 5. 8, then 6. What's the pattern here? What's the relationship between 8 and 6, 7 and 5, 6 and 4? Well, I'm hoping that you have figured out by now that what I'm doing to get from the number of sides to the number of triangles is subtracting 2. 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4, and so on. Okay, so let's use that pattern. We're going to go to the nonagon. And the nonagon, I love the name of this shape, the nonagon. So the nonagon has 9 sides. Now, based on our pattern of subtracting 2, I'm not even going to draw the shape. I know that I have to subtract 2. So 9 minus 2 is 7, which means that there are 7 triangles. And if there are 7 triangles, then I know that I have to multiply 180 by 7. And that gives me 1260. Okay, and we could keep going. Decagon has 10 sides. We're going to subtract 2. That gives me 8. So I would do 8 times 180, and that would give me 1440 degrees, and so on. So here I have a few other shapes. I don't know if I really need to do those. I think you guys have the idea. So here, hendecagon, which has 11 sides, you would multiply by 9, 180 times 9, and dodecagon, 12. You know what? Since I have them, I'm just going to put in what those are if you want to check and try these on your own. So here I have 1620 degrees. And for the last one, I have 1800 degrees. So now we are up to the part where we try to figure out the rule. Now, an n-gon means I have n sides, right? So if I have n sides in this next column, number of sides is n, right? Now, remember, to get from the number of sides to the number of triangles, I have to subtract 2. So the number of triangles is n minus 2. All right. Now, this number right here that I multiply by, right, is this. It's the number of triangles, right? So this number is n minus 2. Now, because it's a binomial, two parts here with a minus in the middle, I'm going to put parentheses around it. Now, what are we multiplying that by? Well, every single time we are multiplying by 180. So here is your general rule. Given an n-sided shape, you would do n minus 2. In other words, subtract 2 from this number of sides and multiply by 180. Now, I don't remember that shape that I asked you guys about in the beginning. I think it was a 732-sided shape, if I'm remembering correctly. So if a shape has 732 sides, how would you figure out the sum of the angles? Well, all you got to do is do 732 minus 2, and that would give me 730, and multiply that by 180, and that's going to give you your answer. You see that? Seconds. That's all it takes. So sum of interior angles of any polygon, once again, you take the number of sides, you take away 2, and you multiply by 180.